just answering questions with WAPTech. If you read the title, you may have a lot of questions. I'm going to try to answer as many as I can. But let's get to the real question of the day. Hi, I have a solar panel array. There's fuses on each of the points. I have lithium iron phosphate smart batteries. I have a battery management system and a Victron smart solar controller. I want to make it to where it cannot be damaged by any radio frequency or electromagnetic noise source, like an EMP, solar storm, whatever. What do I have to do? Also, do I need to put a Faraday cage around anything? Okay, I'm going to bring up something here you may not know about. Either, depending on how you look it up, virtually every government on the planet, but particularly the United States, Britain, and Russia, all about the same time when they figured out that an atom bomb detonated where it wouldn't hurt you and me, but it'd damage equipment by being put outside of the atmosphere almost. They figured out by seeing this happen and seeing the effects that they should make sure that an EMP attack would do not a damn thing. Now, even though all governments play up, the damn Russians are going to EMP us and take away our PlayStation 2 or whatever, none of the equipment you have, in fact, none of the equipment that's ever been built that would be assumed susceptible really was ever. Not because it was designed that way, but because of other rules. Rules that were created by the FCC, Federal Communication Commission, or the equivalent in other countries, that dictated that your equipment should not make noise and interfere with radio transmission and TV sets, or interfere with electronics like a pacemaker, ended up making it to where most equipment internally had something that's called a notch filter or a low-pass filter. What it meant is that any radio signal that hits most of the equipment you know about basically kills it unless it's designed to work with a radio signal. How? By the wizardry of inductors and capacitors? Capacitors, if you're not aware of it, is two or more conductors with an insulator between them. If you're not aware of it, that describes most of the wiring in your house. The power grid, most of the wiring in your computer, has parallel electrical conductors with an insulator of some kind between. And depending on the insulator, the spacing, the effective capacitance, each of these acts as a noise killer for a very broad range of frequencies, or any frequency from one frequency and above. Period. What else can do that? Coils of wire called chokes, or inductors. You know, like the transformer up the street that's powering your house, it's a giant choke. Or the one on the pole pig, as we call it. The pole pig transformer, the thing up on the utility pole. Yeah, it's a big coil. And it's hooked up to, you guessed it, the power line going into your house, which is acting like a capacitor. These circuits are not designed to resonate at 60 cycles a second or 50, but they end up doing it because if they didn't, they'd be wasting energy. So, in effect, the only signal you'll get out of an atom bomb going off, besides maybe some of your electronics actually getting damaged, is a minor surge in power, maybe run your meter backwards. That's about it. The power grid itself might get damaged because of the length of wire involved. How long does the wire have to be before you get damage? And why isn't it as susceptible if the wires are regular wires, like exactly the same wire spaced apart like in a power cord or in your wall? What is the wavelength of an EMP? Well, it works out at being 1 million cycles per second and also all the frequencies below that. This is because it's a rapid increase and then a decrease. It's a very sharp angle. This produces odd harmonics, but it tends to buffer out, because of stuff I don't even want to go into, to be a nice flat spectrum from 0 cycles per second, literally an on signal seeming never to go away and then tapering off, all the way to a rapid vibration at 1 million cycles per second. The entire range is flat looking, and from the pages and scientific papers I looked up. Most of these experiments from the 50s. That's what we got. What's the wavelength at 1 megahertz? Well, that's about 1,000 foot long. So you'd need a wire 1,000 feet long to have each of the nodes for the standing wave to be able to create any current. So unless you got a cable you're dealing with that's 1,000 feet long, nothing there. That's the majority of energy from an EMP. Now this also does to 100 megahertz. So 100 times shorter than that, like 10 feet, would be your your noise figure. Like, you know. And there's also another peak at about 100 cycles per second, 100 feet. Yeah. So, unless you've got really long cabling you're working with, like an electric fence or a fence line, just a fence line, not even electrical equipment, just wire, an EMP like that isn't going to fry anything because it can't create a standing wave over a long enough distance to be able to create a current flow at enough amperage to damage anything. What about really high frequencies? Well, solar storms can produce stuff up to 800 megahertz according to the 2 or 3 sources that would even bother telling me this. 800 megahertz works out to 14 inches. So if you have a cable longer than 14 inches, you have to disrupt this standing wave because it's going voltage up and down on each end of the wire. Well, you put on a ferrite bead. Basically, it's a choke for the cable to get rid of RF noises. It's highly effective. Like, ridiculously so. And it's cheap. You can get 10 of them for $1, 20 of them for $1 if you look on Amazon. And, again, the power cable going to the transformer up the street is probably going to get rid of most of the noise along with that transformer. And again, it's a dead blow hammer to radio signals. It wants to do 60 cycles a second really badly. But if you're worried about that and you have a solar panel and the wires are more than 14 inches long, put fuses on each end for both leads. And across the leads, put in something to get rid of any high voltage spike. And you use what's called a metal oxide varistor. They're literally a nickel a pop. Just put it somewhere in the wiring for each part. Put it next to the part that's most sensitive, which would be the solar panel. All it does is it reacts to high voltage by shorting out the high voltage. It blows itself like a fuse. There's a joke there. But that's fine. You can also get capacitor and choke combinations that are made for RF killing, which kills off noises above a certain frequency, like 100 cycles a second or 10,000 or whatever. They're made mostly for car electrical system, and they're called EMI car filter. So you look up on Amazon. It'll also give you the ones for your house. And on that note, at 120 volts, you get the same sort of thing. It's a different arrangement of the coil and capacitor in a different position, but it's the same kind of thing. And what they are is they're picked so that they will resonate aggressively at anything above a certain frequency, or only resonate at 60 cycles a second for the power line for your house. But for the car, everything above a certain frequency is killed off. It's a low-pass only filter. Now, this means that the capacitor could pop. This means that the coil could get damaged. In the case of your car, it would make a loud popping noise after an EMP went through, and that's it. That would be the only part damaged, and everything else would be fine. And I want to point out that that exact configuration is in virtually every piece of electronics in your car, and virtually every piece of electronics you're going to plug into the wall has the same thing. That power strip you had in the 80s and 90s to plug your computer into, that was really just garbage, but it did have a high voltage killing capability. Same thing. A lot of them have RF filters. If you see an RJ45 jack or any communications jack on there to supposedly kill off any RF noise, or if it just says EMI on it, it'll work fine. And they're ridiculously cheap. You can also get outlets that have these built in, although they're a little harder to find these days. When I ran a lab, I put a metal oxide varistor right across the 120 line on the outlet before I turned on the power, and also put in RF filters in the form of a very small, very high durability, very high voltage tolerant capacitor that would never burn out or dry out. It was designed to get rid of RF noise. And then I would test it. Because instead of assuming it's going to work, I'm going to test it. I'd inject a radio signal and see if it got past the outlet. It didn't. You ran the RF filter to the neutral, from the neutral line to ground, and also from the power line to ground. You had to make sure they were insulated, or you just buy the outlet that has it built in. It's called an EMI filter outlet. It's more expensive, but you plug it in, and one of them will protect most of the building. Or just buy the standard power strip and plug it in and be done with it, because it's the same thing, and just having it plugged into the power system will filter. Yeah, that's pretty much 90% of it. And again, if it's DC based, like a charger for a battery, whether it's going from a paddle wheel, a windmill, or a solar panel, it just needs to be the same thing you'd have for a car. It might need a certain voltage limit accommodated for, but it'll be fine. And if a pulse comes through, its entire purpose is for that capacitor to go bang. In the case of your 120/220 line, the filter won't even go bang. It'll just kill off the noise. You might get a metal oxide varistor go bang, but again, the EMP is done. What about solar storms? They almost never put out enough energy because they spend most of their time at 800 megahertz only. So at that point, really, you just want to worry about the wire length and put in fuses, and that's it. And put in your high voltage bypasses at each end or whatever. Now, what are the other parts of a solar panel set we're going to bring up here? Number one, let's talk about the maximum power point tracker or PowerPoint tracker, PPT or MPPT. It converts any input voltage from your solar panel that's going to have a lot of variation to it and have a lot of load requirements. And it loads down the solar panel to get as much wattage pulled out of it, sucks the energy out of it. And then it uses a switching circuit to make it into the voltage your battery wants and mines the battery. Or it can run a motor. Now, because it could be using, if you're getting one that can directly drive a power system, not just a battery, and also the ones that run a battery, by nature, they include a noise filter because you might be running a drill and it might have really shitty brushes or whatever. So it has to be able to tolerate a bunch of crap happening and snub it or kill off the noise. So it's going to have the filtering into it. Unless you don't have a maximum PowerPoint tracker type circuit, which I don't know of any solar panel company that doesn't make that. They might call it a battery charger or maintainer or a battery management system. But if it's hooked up for solar on purpose, which is what this person's solar controller, it's going to be this kind of circuit. That's smart enough to not only have those filters and cleanups, but to disconnect itself if there's an EMP. It detects not an EMP, but what seems like a shorted out battery, or somebody putting on the battery backwards or something, or the solar cell being bypassed because someone put something on it that shouldn't be there, or a lightning strike. These circuits are exposed to lots of shit, so they're designed to take a lot of shit. Unless it's made by a really shitty company, it'll have these ability. But it doesn't say it'll do EMP. They can't prove in a court of law it's EMP proof because that's really hard to prove, or solar storm proof. But in order for it to be, again, to prevent lightning from damaging it, or preventing you being an idiot and plugging the batteries in wrong or putting the wrong voltage on it, in order for it to be immune to that so it doesn't blow up in your face and cause a fire and have a lawsuit, it's going to by nature also be, by accident, EMP proof and solar storm proof or black hole proof or whatever. Same thing with your car. It's designed not to catch on fire. It's also going to be EMP proof. Period. I mean, literally none of the equipment that you find these days, unless it's by a really shitty company, is able to be damaged by an EMP at all anymore. And again, the frequency range here, again, if the cable's more than 14 inches long, just put, well, here's the deal. If it's DC, any capacitor, small value, very small value, and a large value will do the filtering. Just put that in. Put a fuse in line. If it's shorter than 14 inches, you don't even have to worry about any of this. Your biggest threat will be some idiot with a drill blowing up your circuit because, oh, just plug in for a second, everything's gone because they had really bad brushes and it made a lot of noise. And virtually every piece of equipment in the past had a note on it that's saying the FCC restriction on radio noise or interference. That just meant that it had the same circuits in it at the time, a long time ago. I haven't seen anything from 1940s forward that didn't include something like that in the wiring, even if it didn't mention it. So in short, is your equipment going to need a Faraday cage? If the traces on the solar cells are more than 7 inches long, which is rare, but they do happen, put a bug screen over it and short that thing out. Wrap it around the whole circuit, insulated, and connect it to the neutral line or the ground line, or connect it to nothing. It'll insulate it. But other than that, unless you're running 1,000 feet of cable, you have nothing to worry about. Thanks for watching. Have a good day. Good luck with that.